All right, let's talk about chemical reactions. A chemical reaction is a symbolic representation of what's going on in the laboratory and at the molecular level. If we want to consider copper reacting with aqueous silver nitrate on a laboratory level, we can see that the solution turns blue based on that picture down there for the formation of blue copper 2 plus ions. We can also see the silver metal plating out onto the copper wire. You can kind of see before and after pictures there. So we would react copper with silver nitrate, 2 silver nitrates, and it would form cupric nitrate and solid silver that comes out of solution. How do I know it's copper 2 instead of copper 1? It's because of the blue solution. Certain ions, in particular transition metal ions, do form solutions with colors that are distinctive in aqueous solution. Here are some colors of some common ions in aqueous solution. Copper 1 is colorless, but copper 2 is blue, and that's how I could tell which product was formed. Iron 2 is colorless, but iron 3 is rusty orange. Nickel 2 plus is green. Cobalt 2 plus is pink. Manganese 2 plus is a very pale pink color. Permanganate is purple. Chromate is yellow, and dichromate is orange. And so sometimes you can see by the color of the solution which ions may be present. Now, there are 3 ways to basically write a reaction. The way we have been writing it is the molecular or formula unit equation, and it gives all the reactants and products in the way we've normally been writing it. So copper solid plus 2 silver nitrates forming cupric nitrate and solid silver. That is the way we've been writing it. That would be the quote-unquote molecular equation. The ionic equation, anything that's a strong electrolyte is going to split up into solutions. Remember, that's your strong acids, your strong bases, and your water-soluble salts. Anything that's like just a metal or a weak or non-electrolyte or something that's not water-soluble is not going to be split apart in the ionic equation. The net ionic equation eliminates what we call spectator ions. They're ions that are present, but they don't really do anything. They don't change physical state. And those can be eliminated. They're there because you can't just say, go to the stockroom and grab some silver ions. They have to be part of some salt. So you need to do that. So what we're going to do is we're going to write the imbalance, the ionic, and the net ionic equations for the copper metal reacting with silver nitrate. And want to be sure in each of these types of reactions that we're going to write going forward that you write the state, because it's going to be important as to whether it splits up or not. So if we look at this particular reaction, these 2 things are water-soluble strong electrolytes because they're water-soluble salts. There's really nothing to split apart in the silver and the copper. We'll do some more of these as we progress in the chapter. But you're going to need to remember those water solubility rules from the electrolytes and water solubility section so that you can predict this yourself moving forward. So this would be molecular. So then we're going to need an ionic. We're not going to split apart the copper, but we are going to split apart the silver nitrate. So we're going to end up with 2 silver ions because there's a 2 coefficient out front, and 2 nitrate ions. We're going to split those ions right apart. We write them separately with a plus sign in front. Then we're going to, cupric nitrate is going to split apart, so we're going to get Cu2 plus aqueous. Now there's a 2 down here, but now that's going to have to come out front when I ionize it. So 2NO3 minus aqueous plus the silver. So that is all the things and the way in which they would be shown in solution. Now, when I write the net ionic, what's my spectator ion? The nitrate's just kind of hanging out. The copper's changing charges, and so is the silver. So something's happening to the copper and the silver, but nothing's happening to the nitrate. So that's my spectator ion. Think of it like you're in a sport. You know, you go and you watch the game in the stands, but you don't really play, right? So you're a spectator. So it's kind of hanging out. So that is what's going to go away. And then in the net ionic equation, I'm going to end it with copper solid plus 2 silver ions, reacting to form Cu2 plus aqueous plus silver metal, and that is my net ionic equation. Again, we'll do some of these as we go through the different types of reactions as well.